A single F1 piston, including its development and manufacture, can cost over £50,000. So I went to Cosworth to understand the life of a piston, and it was genuinely one of the most interesting days I've ever had. The design process takes 4 to 8 weeks depending on how far the team go with the optimization of the piston. Once the piston is designed, it's time to head to manufacturing, and the process begins with forging. Here, a small billet of aluminium is heated to between 400 and 500 degrees Celsius, and then shaped into the piston using a huge press. So the piston is forged and it kinda looks like the final product. Surely it's time to get it machined. Well, actually no. First, the team need to program the CNC machines. Now these things are huge and extremely complicated. So once the design has been approved, the drawings and the software designs are forwarded to the programming team, who will then program the designs for the machining process. Depending on the complexity of the piston design, it usually takes between 30 and 50 processes on the machine to finish each piston, and an entire batch of pistons can take 4 to 6 weeks to be produced. The machining begins on the underside of the piston, removing material that wasn't possible to be removed during the forging process.
So this piston has no crown machining yet. We've just undercrown machined, so put a pin bore in and done all of these undercuts.
Once this is done, the undercrown is polished to remove any marks and smooth out the surfaces. Then the piston is turned over and the general crown shape and the valve pockets are machined.
We've already turned it to kind of a nominal diameter, but we've now machined on all the crown features. So this would now be ready to go into the Takasawa and have the turning.
And this is where things get even more precise. This is a Takasawa CNC machine. It's basically a high precision lathe, and it's used for turning the piston and shaping it to very precise dimensions and tolerances. It can work with precision down to just a few microns. Then the final part of the piston to be machined is the pin bore, the hole in the piston where the piston pin or wrist pin connects the piston to the connecting rod. Once the piston machining is finished, it goes through a final rumbling process and then gets coated. Even though the DLC coating is very thin, measuring just a few microns, it's carefully accounted for during the machining process to ensure all the dimensions remain precise. Throughout the entire machining process, the piston undergoes multiple inspections for finish and dimensions. This includes both manual checks and measurements using a coordinate measuring machine, or CMM. To ensure safety and reliability, pistons must be checked for cracks. To detect these cracks, the team performs crack testing using a penetrant dye that glows under UV light, coated with the penetrant and left to allow the dye to seep into any cracks. After wiping away the excess dye, the part is placed under UV light, where any cracks will be highlighted by the dye that remains in them. So with the pistons checked for quality, it's finally time to assemble the engine. The build takes place in the build shop, where the piston is combined with other engine components. Like the rest of the facility, the engine build shop is absolutely spotless, and it's temperature controlled to ensure all the parts are precisely sized and fit together perfectly. The team follows a build plan to ensure the engine is assembled properly and all bolts are tightened to the correct torque, and then components like the valves are set up correctly.
Measuring how far up and down the valve is going to move.
While I was in the shop, I got to see an old F1 block with the pistons installed, and it was fascinating to see how the pistons move within the cylinder, and just look at how short the stroke is.
You can see there's really not a lot of difference between top dead and bottom dead centre.
Then, once the engine is fully assembled, it's time to put it to test on the dyno. The dyno is a critical part of the process where the engine's performance and durability are evaluated under controlled conditions. For a new engine, the dyno testing process is comprehensive, involving a series of durability tests and simulations to ensure the engine can handle the demands of racing. Once the engine has passed all its tests on the dyno, it's ready to leave the factory, get installed into a car, and finally hit the track.